This is the fourth mini lecture for section 3.2 of the textbook, or section 3.3 of the syllabus. Now let's illustrate 264 minus 179 using a place value diagram. So we make a chart with three columns for hundreds, tens, and ones. We're starting with 2 hundreds, 6 tens, and 4 ones, and we're taking away 100, 7 tens, and 9 ones. Of course, we can't take 9 ones away from 4 ones, and we can't take 7 tens away from 6 tens. So we're going to have to make exchanges between the columns. Step 1, we're going to exchange 1 10 for 10 ones. So now we're going to have 2 hundreds, 5 tens, and 14 ones. We're still subtracting our 1, 7, and 9. And next, we exchange 100 for 10 tens. So we have 100, 15 tens, and 14 ones. We're subtracting 100, 7 tens, and 9 ones. Now I can subtract 14 minus 9 is 5, 15 minus 7 is 8, 1 minus 1 is 0. And so there's the answer. Now compare this with the final algorithm for subtraction that you learned in grade school. 264 minus 179. Okay, step 1, we make an exchange. We exchange 1 10 for 10 ones. So we have 14 ones now, rather than just 4, and we have 5 tens instead of 6. And I go ahead and subtract at this point. 14 minus 9 is 5. Okay, I can't take 7 tens away from 5 tens, so I make an exchange. I exchange 100 for 10 tens, and now I've got 15 tens. And 15 minus 7 is 8 tens, and 1 minus 1 is 0, and so I get 85. But notice that the exchanges that I made here were exactly the same as the exchanges I made over here. Just over here, we're expanding it out so we can really see each individual step. When you use a place value diagram, don't cross things out and write little numbers at the top. That's what we do in the final algorithm. In the place value diagram, which we also refer to as the instructional algorithm, that's for subtraction, we have everything expanded out. We don't hide anything. We don't cross things out. So remember, when you do the homework, if the textbook asks you to illustrate subtraction using the instructional algorithm, do this instead. Do the place value diagram. Now, this next material actually comes from section 3.5 of the book, but we're covering it here because we're talking about addition and subtraction now. The algorithms for addition and subtraction work just as well in non-decimal positional systems. So let's perform the following sums and differences in base 5. And we're going to convert to base 10 to check our work. For example, suppose I want to add 3, 4, 2 plus 2, 3, 3 in base 5. So these are supposed to represent base 5 numerals right now. Okay, 2 plus 3 is 10. I'm sorry, 2 plus 3 is 5, of course, but in base 10, in base 5, we write 5 as 1, 0. So let me repeat that because I kind of stumbled. 2 plus 3 is 5 in any base. 2 plus 3 is 5. But in base 5, I write 5 as 1, 0, because it's 1, 5, and 0 ones. Now 1 plus 4 plus 3 is 8, and that's true in any base, it's 8. But in base 5, I write 8 as 1, 3. So I'm going to put a 3 here, carry the 1. 1 plus 3 plus 2 is 6, but in base 5, 6 is written as 1, 1. So I get 1, 1, 3, 0. Now let's check our work. 3, 4, 2 base 5 is 3 times 5 squared plus 4 times 5 plus 2. So let's see, we have 75 plus 20 is 95 plus 2 is 97. So base 10, this is 97. Base 5 is 3, 4, 2 base 5. Okay, 2, 3, 3 base 5. 2 times 5 squared plus 3 times 5 plus 3. 3 times 25 is 50, plus 15 is 65, plus 3 is 68. And then 1, 1, 3, 0, base 5. It's 1 times 5 to the third power, plus 1 times 5 squared, plus 3 times 5, plus 0. Okay, we have 125, plus 25 gets us up to 150, plus 15 is 165. And if I did my work over here correctly, when I add 97 to 68, I should get 165. So now I'm doing a base 10 addition. 7 plus 8 is 15. I make an exchange. 1 plus 9 plus 6 is 16. I get 165, and that works out then. So yeah, don't be confused by this. When I write a numeral in base 5, that's just a different way of writing the number that we've always known. So when I write 3, 4, 2 base 5, that's just a different way of writing 97. Okay, when I do a sum in base 5, I'm just using a different system for keeping track of things. But the answer I get should be the same no matter what base I did the work in. So this isn't 342 plus 233. This is 342 base 5 plus 233 base 5. Or, in other words, what we usually call 97 plus 68. Now let's try a subtraction. Let's say 402 base 5 minus 143 base 5. Now here, I can't do 2 minus 3, so I'm going to have to make an exchange. There's nothing in the 5s column, so I'm going to have to start with the 5 squareds column. So I'm going to exchange one of those for 5 5s in effect, but 5 is written as 1 0 right now. Then I make another exchange. 1 0 is 5, and so when I take one away from that, I get 4. This becomes 1 2, which for us is 7. So 7 minus 3 is 4. 4 minus 4 is 0. 3 minus 1 is 2. And I get 204. Now let's check. 402 base 5 is 4 times 5 squared plus 0 times 5 plus 2. See, we have 100 plus 2 is 102. 143 base 5 is 1 times 5 squared plus 4 times 5 plus 3. 25 plus 20 is 45, plus 3 is 48. And then 204 base 5. 2 times 5 squared plus 0 times 5 plus 4 is 50, plus 4 is 54. And now I'll subtract to make sure that we got the right answer. 102 minus 48. We get 54, so our work was correct. Okay, on the homework, you'll do some of these for base 5 and for base 6. So note that the homework includes exercises from section 3. I said 3.3, that should be section 3.2, sorry, and also section 3.5.